So welcome, ladies and gentlemen, to the ITER booth here at the 29th party of the Conference of the Parties, or better known as the COP29. So we are here with the ITER organization to hold up the fusion flag, but we are not alone because we are a huge world-spanning community on the quest for fusion energy. And so we invited friends from the community, from other organizations, from the private sector, startups, and DOE to come and join us and to tell us a bit more about the importance of international collaboration. This panel is hosted by the Clean Air Task Force. So it's the spiritus rector of all this is Cehila Gonzalez here with me. You will tell more about the Clean Air Task Force and why you're doing this. And yes, and with this, I hand over to our Deputy Director General, Luo DeLong, who will welcome you on behalf of the organization.
Thank you, Sabina. And my name is Luo DeLong, and I work for the ITER organization as Deputy Director General for Corporate. And very pleased to have you all here, welcome you, and thank you, the panel, for joining us. And the main purpose for this panel is to address the international collaboration. In fact, ITER is one of the largest international cooperation projects. And the reason is that fusion is not for today and tomorrow. Fusion is for the day after tomorrow. We need a long time to realize fusion. So it's a long process for fusion, especially commercial fusion development. So that we really need international cooperation, and international cooperation will speed up the process of the commercial fusion energy development. So this is why we are here and trying to know more and trying to explore more about international collaboration. Particularly, we will introduce two other international projects. One is IFMIF-DONES, another is an international database run by the Clean Air Task Force. So all these will be examples of international cooperation. So by saying that, I would like to ask the panel members to introduce themselves. From Sheila, please.
Thank you, and thank you for hosting this event at the ITER booth. It's always a pleasure to be here. I'm Sheila Gonzalez. I'm the director of the Fusion Program at Clean Air Task Force.
My name is Anders Wolf. I am CEO of Supra, a Danish superconductor company, and I'm also the vice chair of the European Fusion Association.
My name is Gail Hauk. I am a senior research staff at Oak Ridge National Laboratory in the Fusion and Fission Energy Sciences Directorate.
Andrew Smith, Director of Communications for the American Nuclear Society. It's an honor to be here. Thank you.
My name is Jose Aguilar. I'm working as a Program Management Office Leader in IFMIF-DONES, in the IFMIF-DONES project. Pleased to meet you.
Thank you very much for the introduction. And in the following hour, I will ask questions to the panel members for them to answer, and then finally we will have some time for discussion. And I would like to ask the panel members to answer questions briefly, because we are really we have time limit. So that I will start to ask questions. The first action is to Andrew, and I would like to ask how can international cooperation speed up the fusion development, and what are the boundaries and the limits for this cooperation, please?
Great. So international cooperation, I mean, rather than dividing up our efforts and spending those resources, we're bringing the best of our scientists and engineers together to develop fusion energy. ITER itself, is keystone of that, key figure piece. And beyond that, beyond just ITER and all of our facilities that we're pursuing on this, our professional societies like the American Nuclear Society, the European Nuclear Society, and others, these are forums to share technical knowledge and bring research together and publish it in journals. We have the Technology of Fusion Energy Forum that just had its 26th annual meeting, I believe, this year. I know that Europe has one as well, and these bring people that are scientists, developers in fusion all around the world together. So the idea of speeding that up through international cooperation is key. It's just a further development of atoms for peace back in the 50s. In addition to that, I don't know if there's necessarily any limit to that cooperation. I know my colleagues up here would probably have more nuanced response to that. And as long as we keep on focusing our efforts together on developing fusion, potentially there could be no limit.
Thank you. It sounds that we don't have any limits. Good. But my next question is to Sailor. What is the Clean Air Task Force program on fusion is doing? And why is the construction and the maintenance of the international database for fusion materials included in the program?
Thank you. Well, just to say a few things about the Clean Air. Okay, just to say a few things about the Clean Air Task Force Fusion program before we start. The first thing is we started that program 1.5 years ago or something like that, and it's mostly based on cooperation with the academia, cooperation with the private sector, cooperation with national lab, with policymakers. So it's all about cooperation and pushing fusion towards an industry approach. So we are moving now to commercialization, and we need to tackle a number of points that maybe they are a little bit lost because they are not lab specific, they are not industry specific, and we are taking care of that. So we have 4 pillars. One is development of technology. The second, de-risking fusion, is all about safety and regulations. The third one is becoming an industrial environment. And the fourth one is making the case for fusion. This is particularly important because fusion has to be part of the clean tech environment, and we need to make that case and also explain to the policymakers that fusion has its own advantage, its own features, and how to implement the right policies. So within this program, the international database came as a request from the community because cooperation saves time and money. We need to organize data. These data are here and there, and by making that effort of putting together data, we organize what is available. We sort it out in terms of quality. Decisions can be taken by policymakers on which is needed and which is not needed. And also it provides the advantage of using artificial intelligence into that data that so far cannot be done because you don't have this proper database. So a lot of implications, also in terms of safety and codes developments, an international effort, and this is why CATF is taking care of that. Thank you.
Thank you, Sheila. The next one, I would like to ask Jose. What is the IFMIF-DONES program, and why this program is important, is needed for ITER or for fusion?
Okay, thank you. Well, IFMIF-DONES, as ITER, is an international project where is in Spain, the facility. We are constructing now the facility. We are working in the program, in the DONES program, from several countries, mainly from the European Union and from Japan now, but because we are open to new contribution to new countries. What we need in IFMIF-DONES? We need IFMIF-DONES because the international fusion energy community has to attend one of the fusion challenge that we have, and this is the challenge of the materials. What material we are going to use in the future to build the machines to reproduce inside the fusion energy? This is the challenge that we want to attend to try to solve in IFMIF-DONES. We are working on it.
Thank you, Jose. And my next question is to Gail. how can research organizations like the U.S. Department of Energy and the national laboratories contribute to fusion development and support the international collaboration? Gail, please.
Thank you. An excellent question, and I feel that the U.S. national laboratories and other national laboratories as well in other countries are so well suited in between the academic and the practical. Our role is really to go from the ideas to the implementation until it's ready for a company to take it and to move forward with it. As we all know, fusion is a very interdisciplinary effort, and it needs a wide range of technical capabilities. And for those that don't know about Oak Ridge National Laboratory, we are one of the very first national laboratories in the world, and we have everything from basic sciences, splitting atoms apart and looking at the building blocks of the universe, to biotechnology, looking at biofuels, natural laboratories. There's a fish laboratory there, and then more on the applied side, like myself, working on commercialization and energy. So with that set of broad capabilities, our national lab has the opportunity to, for example, do material design and run it through code, and then build that material in our 3D manufacturing laboratory, and then irradiate it in our high flux reactor, and then take it to our hot cell and take it apart, and then do the analysis on it. So we have an ability to move very quickly through some of those steps that maybe would hold up our research and development. And because of that, we've seen a lot of partnerships, public-private partnerships with Oak Ridge National Lab, partnering with 20 different fusion startup companies, and working with a lot of different organizations to help move the progress of the research forward. We're also leading the development of some of the critically needed facilities. We have this opportunity to get funding, federal funding from the U.S., and to be able to build some facilities that maybe a small startup fusion company would not be able to afford to do. And then we can partner together with them. But we have the U.S. ITER program, the materials plasma exposure experiment, and then working on building the fusion prototypic neutron source, and some test stands that will be able to partner even more with fusion companies.
Thank you, Gail. It's further to that, international cooperation is important. In the meantime, the cooperation within our fusion sector is also important. To that end, I would like to ask Anders to answer why this is important within the ITER sector. Within the fusion sector. Sorry.
Within the fusion sector, yes. So I think I'll answer that with my hat of being from the European Fusion Association. If we're going to have any chance of putting a power plant either in the US or on the continent of Europe, anywhere, we need to accelerate immensely right now. And as you said in the beginning, we need to collaborate. Everybody is clear about that. The situation in Europe is so that we are having a stalling economy. We have no further growth engine right now in Europe, and we need to have that. Fusion could be that growth engine, but it fosters that we have collaborations between the companies who are able to be the supply chain and the companies willing to do actually the assembly of all the components into whatever fusion power plant we can have. So what we are advocating for in EFA is basically the acceleration. We should be having industry leading the next path, learning everything we can from all the fusion sites, the big science parts, and saying we can have also engineers, technicians, and so on being skilled in the art of fusion at, for example, ITER or in the IFMIF-DONES in the future, and coming out into the companies, building the power plants. That's all what it's about, accelerating towards that. And collaboration is key.
Thank you, Anders. And then Sheila, how do you see the international cooperation will shape global industry like fusion?
Well, fusion has been since ever an international endeavor, but one thing is to have an international endeavor from the research part, and different things to have a global industry. Fusion needs to have a global industry because we need to have a global market. Fusion companies want to have a global market where they can sell their products, the fusion machines, and to supply energy to everyone. And with that particular idea, work towards harmonization in different areas, like the ones that we are tackling at the Clean Air Task Force program, like standardization, this international database where all data will be set up in a standard way, so you can really later apply artificial intelligence techniques, and not only that, to be used by all the users with a confidence that you are getting what you need, and not any strange data that at the end is useless. All these elements related to safety, regulation, industrial standards are key to set up an industrial sector that has to be global, and we have the opportunity to make it global in Fusion. So let's work for that, and this international collaboration is the key element to work along that lines, and teaming up with different organizations, teaming up with IFMIF-DONES to get the data into the international database, teaming up with Outreach to get all this information in a standard way, teaming up with the Industries Association to apply that standards is one of the essential points of this discussion, of the CATF program and the Fusion community.
Thank you, Sila. And the IFMIF-DONES program is really a large facility for material testing. And this is, I understand, is run by Japan and Europe. Do you think this can be integrated into international cooperation? If so, how?
Well, yes, and now is an international project with the members, and these members are coming. We are 17 countries, all the 16 countries from the 15 countries, sorry, from the European Union, plus Ukraine and plus Japan. This is the picture now, but the DONES program is absolutely open to the international collaboration. For example, we are having some contacts with other countries, for example, with the United States or with the United Kingdom, in order to have these countries in our facility. We have to understand, we have to know that in the future fusion devices, we can speak about tokamaks, we can speak about accelerator, we can speak about ignition fusion facilities. In all these fusion devices, we are going to have neutrons. Neutrons, very, very, very special. The neutrons, the fusion neutrons. That the energy is similar, that is the energy that we are going to have in the future after the fusion reaction. And IFMIF-DONES finally is going to be the facility where we are going to try to validate, to check, to test all the material that we are going to use in the future, not now, but in the future, during the next years, during the next centuries, in order to understand what are the best materials to build these machines, these complex machines. Then the international DONES program is absolutely open to the international collaboration from countries for the public sector, and in addition, we are open to the private collaboration. We are open to discuss with companies, with organizations, in order to know what are the common points that we can have together in order to create international collaboration project together to attain the different technologies that we are in this kind of project. Finally, it's not only in IFMIF-DONES. For example, there are topics like, for example, remote handling. The remote handling in all the large infrastructures in the world, we are going to need in the future remote handling, very special remote handling, very accurate, very etc. Then, DONES, IFMIF-DONES and the DONES program is an international project. Now we have members, but we are absolutely open to the international collaboration.
Thank you very much. And Gail, based on your experience working with US ITER and the Oak Ridge National Lab, what do you think are the difficulties or barriers for international cooperation? If you feel so, how we can overcome? I continue to ask this.
Yeah, I think a lot of the barriers we've really kind of talked about with the international collaboration in, we want to make sure that we are not duplicating efforts between organizations and reinventing the wheel over and over again and sharing. But we also need to make sure that sharing and that collaboration isn't slowing us down by being too siloed and not being able to move from one part of the research to another. Climate change is an international problem. It needs international solutions, and I think that's one of the most exciting things about Fusion and the opportunity there for that international deployment of the technology to address global climate change. In terms of what Oak Ridge is doing, we are a not-for-profit organization. We're not trying to make money from the technology. Our role is really to look for where are the gaps and where are the things that other organizations can't do, and to step in and to fill some of those goals. So we're really working to be synergistic with the other national labs and international partners, filling those gaps and working on those capabilities that are missing to be complementary both in the public sector and in the private sector elsewhere. Oak Ridge obviously has the U.S. ITER project, which is working with our international colleagues to develop a critically needed platform for burning plasma studies, and also providing invaluable experience in design and construction of a power plant scale fusion system. We're always looking for new ways to work with our international partners. For example, Oak Ridge and the UK Atomic Energy Authority are exploring ways to share capabilities and work together on remote handling, blankets, and tritium. So I'll leave it with that for now.
Thank you, Gabe. And then to Andrew again. Based on your experience, how the professional societies will facilitate the cooperation between public and private sectors. And you have mentioned a little, but maybe you can further explore on this. And who really owns the large testing facilities in the world, and how they can interact with each other for potential use.
Great. So professional societies like the American Nuclear Society provides a forum for exchange of information. I mentioned this earlier. We have forums like the Technology of Fusion Energy, which meets annually. It brings people together around the world, scientists, researchers, developers. Okay, I was trying to make sure there was no feedback. But that exchange of information comes not only in person and having those discussions, face-to-face meetings, but also through our scientific journals that get published by the American Nuclear Society and our counterparts around the world. And that's very important. It's very much an international effort that we continue to see. On your question about the testing facilities, I know Gail was talking about Oak Ridge, that being a national lab in the U.S. Other national labs have such facilities. In private-public partnerships plays a key role in that because you have General Atomics, D3D facility that's in San Diego, California, and that gets to an example of a facility that's privately owned, that's working with government support, private-public partnership, and it's a national user facility. So the Office of Science for DOE controls grants permission on users that could gain access to it, and you gain access to like unpublished data, knowledge of upcoming projects and research for that. And another example, we have universities across the U.S. have testing facilities and fusion programs from Princeton's plasma physics lab to North Carolina State University has just started a fusion program and that they're building. And those are also supported by private-public partnerships. And the students and faculty that are at these programs, they come together at these professional societies to exchange information, show the research, present papers, and so on. So it plays a key role, just like how the development of fission back in the 40s and 50s and 60s was furthered by coming together at these professional society meetups and conferences.
Thank you very much, Andrew. And then Anderson, you mentioned that you were representing the European Fusion Association. And what exactly the goal of your association, please?
Accelerating in Europe. So maybe starting at a different place, saying that the things that are happening in the US and in China is fantastic. From the point of view that you have, $8 billion now coming into the private fusion sector, into the fusion companies, and we should salute that. We should have much more than that. And Europe right now is constituting 11%. I'm including here UK as part of Europe, of course. And 11% is, to some extent, you can watch and see that's a disaster. It should be on the same level as the US and China, what they're putting in. So if we can actually say, again, we have ITER in the backyard. We have the largest fusion reactor being built here in Europe. We have all the skills, we have all the companies, we have the supply chains. Accelerate. And this is really coming back to what the European Fusion Association is doing, in collaboration, of course, with the Fusion Industry Association across the Atlantic, that joining forces and say, couldn't the industry actually lead this to a level where we have the same kind of commitment from Europe? And I would say also with the knowledge sharing, it's immensely important. So we need tech transfer. So what ITER is also delivering is technology that is ready to be harvested by industry. We just need to bridge the tech transfer with the private capital. And of course, from the EU side, we need to have the lion's share of the capital being covered by EU. Then you could have potentially the growth engine I mentioned before, with an industry flourishing and having a renaissance of the European industry to match up against that was the wrong wording, together with China and US. So the entire globe is running the race instead.
Thank you, Anders. And then I have questions for the whole panel. Anyone who wish to answer this. First is the data, and adequate databases can facilitate or speed up fusion. I would like to ask why and how.
Okay, to build any fusion machine, you need data. And data costs time and money. So by putting together and cooperating with the data, the generation of data and the storage and the categorization of that data is one of the key elements to push fusion. Not only at technical level, many of the regulators, many of the decisions that imply licensing of fusion is based on those data. So data and the mechanisms to use the data needs to be in place if we want to speed up, and we need to go faster. And this is one of the things that we are at CATF putting together with all the whole community, and it's a transversal exercise with US, UK, and Europe involved in that database. Examples like that, we can find it in other places, and transfer of knowledge, as has been mentioned, is a key element. But again, to find the mechanisms, how to transfer that knowledge where the IP issues are not affected is also a challenge, and we need to find solutions for that. Thank you.
Thank you.
The data is knowledge. Knowledge is data. Finally, no. And this is the summary for me of the answer to your question. Thinking in my project in IFMIF-DONES, obviously the data are in the center of all the things. But the data is not only the data that we are going to have in 10 years after the experiments that we are going to carry out in the facility. Obviously, they are going to be data, very interesting data for the international fusion community. the data are now in our project. The design is data, because now we are constructing in the IFMIF-DONES facility in Spain. It's an international project, but in the future we are going to need more international fusion irradiation facilities for materials, for fusion materials. This is a fact. Then in the future in United States we are going to need a specific facility for the irradiation of fusion materials with neutrons similar to fusion, and in Europe and in Japan and in China obviously, and finally in the world. We are going to need fusion devices, and we are going to need complementary facilities in order to extend or to have more information, because the fusion is finally the way, because we are not going to arrive to a finish in the way to the fusion. It's like the car. Finally, we are developing a new energy, and we are continuously to improve the things around the fusion energy. Now, in our case, one of the things that we are discussing in the DONES program with all the members of the DONES program is how we are going to manage the current data and the data of the future. This is one of the key points that we are dealing now. We are speaking now, and it's very, very important.
And I can just add briefly, because I come from the commercial industry. I worked in the commercial fission industry for about 20 years, and we are generating so much data. It's the retrievability of that data that is really the most complex part of the data, and having some of these international databases and the collaborations that we've been talking about are so important for that ability to get that data and share it together and have it accessible and in a form that is useful going forward.
Just very short comment to this, that having the data accessible is one thing, but also having companies or institutions thinking about programs where when you are trying to actually use the data for, let's say, figuring out how the steel is going to degrade, or how you're going to make superconducting coils, or whatever materials that you need, how are they going to perform in due course. Having those programs also being matching the data types for the future, also looking towards even faster data processing, AI and so on. I think that will also be something really to implement very, very soon.
Okay, thank you all. And my next question is that we understand that fusion is a frontier nuclear program. And for this, we have issues like intellectual property, similar to other frontier technologies, and also export control, and also the data storage and databases, how they can use and who can use. So all these questions how these questions would influence our future fusion policy making.
Maybe I can take the point of what I heard the first word you're saying, regulations. That in the US and in Japan, very cleverly not thinking of a fusion machine as being a fission machine. It's entirely different. The radioactivity and the decay times and so on for these materials is a completely different thing. You should be analyzing a fusion machine as being an accelerator to that extent, and they've done that brilliantly in the US, and we should have the same here, so that we can actually have it as an accessible platform for letting also private companies, in collaboration with public-private partnerships, enter into a completely new arena where you can utilize all the data that you're speaking of and make it become into machines that you can build, because the regulations are not hindering this.
You make the exact point. Fusion is not fission, it's a different thing. And that is something that policymakers, regulator needs to keep in mind. And we, the fusion community, need to teach them. which are the features of fusion, which are different, and the regulation and the policy, the regulation should be adapted to that, or should be. I don't like to say adapted because it's like you are taking something that already exists and you shape a little bit and you make the case. No, it needs to be developed for fusion. Understanding what fusion is, the risks, the hazards, and the potential consequence of whatever, and make it fusion specific. This is the key. And when you have this understanding, having this global harmonization in this aspect, it comes basically by default. So pushing for that is one of the main things that we are doing, and is how the fusion community, in my view, has to make the effort to show that difference, to show what fusion is and what is not, which sometimes is most important. And policymakers should take notes about that. So.
Again, as someone coming from industry, I think a lot about commercialization and how we're moving from the research mode into the deployment mode. And I think this is really an area where I haven't seen a lot of discussion in the fusion space, and maybe we're not there yet. Maybe it's too early to be talking about what are the business models that are going to be associated with the deployment. How are we handling the export control, and do we have the right laws and regulations and policies in place? I agree they should not be, I don't like the idea of we keep putting Band-Aids on the problem and hopefully we'll end up with a fusion regulatory framework. It's not the right approach, right? It's a different technology, different risks, different benefits. So if we are developing that now, it will be ready, I think, when the technology is ready. But I worry that that's an area where, as scientists, we get very excited about the technology and we get a lot less excited about business models and supply chain and how that's all going to fit together. So that's something that I'm hoping to see more of in the next few years.
Really like to comment on this because I am industry. So I'm a supply chain company as well. The super here. We're producing superconductors and representing an industry organization working for industry in Europe, having a global outreach through collaboration, for example, with FIA and so on, seeing that we already have basically the supply chain which is delivering fusion components. So you need so many components which has nothing to do necessarily with neutrons, but it could be the cooling for some systems, it could be the lasers from Trumpf or Thales and so on. And over to all the structural facility components of making a power plant, which is the ultimate goal. And I completely agree. We could start building all those parts right now. And when we have the final solution, we'll put that in the center. Could that be something? Already start building power plants and have it flexible enough to have the final solution coming afterwards. Just a thought.
If I may add something at the end, I appreciated your comment because the thing of no one or not too many people are looking at that issues. Is this what we do at CATF? Look at that issues that industry is busy building things. Okay, labs are doing research and we are understanding what is needed and looking at that mechanism, provided all the information to policymakers to really go into the right direction. So I think it's a good conclusion of that. Thank you.
Okay, thank you all. In fact, we are talking about data, databases, and all this data, no matter where it comes from, all past experience from testing facilities, all this data could be used in another form. It's AI, artificial intelligence. So tomorrow, same time, same place, we will have a panel.
Same time in the morning.
I thought it's same time.
Same place.
Same place, and we will have another panel concentrating on how AI would speed up our fusion development. So you are welcome for that. Coming back to the session here, we are here for COP29. All the countries are encouraged or requested to reduce or eliminate carbon emission. This is something we are here for. So that I believe that what we are doing here for fusion is going to make a contribution to this carbon neutral. So that by saying that, I would like to close this part of this session, and I will give the floor to Sela to give you information about how to approach the international database. And then we have questions and answers, if you like. Please.
Okay, being fast, we have, just to be precise, we have the panel tomorrow at 11 here.
Yes, please.
So same place tomorrow in the morning, a.m.
11 a.m.
Yeah. And how to approach the international database, easy. You just contact me. You can go to the web of CATF and find my email, or I will give you my business card. It's a collection of private, public entities and the academia contributing. We are engaged with IFMIF-DONES. We are having also with Outreach. We have Eurofusion, the UKA. So the more people, the better. The more suggestions, also the better. So thank you.
Thank you very much. And
Questions?
then, any questions or to our panel?
I think we are going to have some drinks there.
Yes, there are some drinks and yeah.
Questions over drinks.
It's,
Questions over drinks is always better.
to promote more questions. Yes, please. Microphones? No, it's better a microphone because we have record over there.
Great, thanks. I'm not just on the drumstick. Yeah. Oh, yeah. Hi, my name's Ross Matskin-Bridger with the Nuclear Scaling Initiative. A fascinating conversation, really fascinated with fusion. What I'm really wondering about, so we're talking about speeding up fusion deployment, and I'm wondering kind of what the time scale is for that. And I understand it depends on how we deploy all these tools, but do you have kind of like a pessimistic and an optimistic time frame for when we might actually be looking at deployment? Thank you.
Thank you.
Fantastic question, which has been asked many times, and I think to be fair, it depends really on who you are asking. If you're asking the people who are making the sure path for demonstrating that this technology can work, then it's a long time frame, and it should be, because you need to be actually the benchmarking for all others to look at. If you are asking the ones who are risk willing, who has the capital, let's say SpaceX kind of approach, then you're looking at somebody who has the financing and the willingness to fail. And from failing, you learn. And if you can rise up again and do it again, you will improve. Having the two collaborating means that some timelines are very, very aggressive and very, very short. If you look at Helion, they are promising 2028 to deliver 50 megawatt of power to Microsoft. Fingers crossed that will work. Then we can start working and play golf instead. If we're looking a bit more pessimistic, we're in the 2050s, 2060s. But let's say if you could actually have the private-public partnerships working towards making these timelines bridge, it will be somewhere between those timelines. And there are a lot of fusion companies saying they can move faster. I believe they can move faster because they have the agility and the risk willingness to do so. But you need to have the support from, for example, ITER, with all the knowledge. You need engineers and so on, tech transfer at a speed not seen in fusion before. So we also need to accelerate to make that timeline change. I hope that was some question, or some answer to your question.
If I may add something. Sometimes when people ask that question, which is the question that everyone to have the right answer, obviously you want to have it fusion tomorrow, you need to distinguish between what is a scientific machine, what is a prototype machine, and what is a commercial machine. Timelines are different, okay? So we are now in the era of scientific machines. We want to build prototypes. And in these prototypes, you will have something which is new for fusion, which is integration. It's being done on ITER somehow, this integration of the whole component. This is a crucial path. And this is where fusion industry and fusion community is going to need the push and the support of the private sector and the public sector. And when I say the public sector, I say the governments. And then after this prototype, you will go into the era of the commercial machines. So how fast we move into this transition from scientific to prototype to the commercial machine will depend on the support, economic support, and also how efficient the fusion community is using these new tools and information available to speed up all the process. And then you have all this range, as Jan says, about all the private companies explaining their timelines and so. But regardless of that, experimental machines, prototypes, commercial. This is the line that everyone needs to follow, and we need to speed up.
In fact, ITER has got 7 members, China, EU, India, Korea, Japan, Russia, and US. And all these 7 members have got roadmap for fusion development. And one day we're reaching commercialization of fusion. And this roadmap range from 2045 to 2060. So that's really a range, and for at least for after ITER is demo, and then we can have real commercial reactors. So to that end, I believe this is quite a common sense by the ITER members that around 2050 we will be there. So this is why I said we can make contribution to carbon neutral.
Lisa Marshall, Assistant Extension Professor at North Carolina State University's Nuclear Engineering Program, and also the President for American Nuclear Society. We see on the fission side a push for human capacity building, and for that to be more proactive, right, as we look at the deployment of our various advanced fission reactors. As we're working in this area, and we're seeing a leapfrog from when I came into the industry 22 years ago. Are there particular initiatives by private or professional or national labs, government, etc., to have the interest and the workforce ready as we move from prototype to commercialization?
Not enough. I think it's the clear answer. It needs to be many doubled. The skills, the knowledge needed to really go from prototypes into industrial production of power plants. And I hope we don't have to wait for ITER. I hope some of the private companies and the industry can raise up and actually speed up this process. Of course, still having the benchmarking from all the big science projects. You need that, because that's where you're probably going to have all the technical skills from, which are needed to make this transition. Can that happen in a much shorter time frame of, let's say, 10 years? We've seen magnificent things happening, and as you say, a quantum leaping of technology. Well, just 20 years ago, how big was a mobile phone? And now we're speaking about basically the mobile phones are the same capacity as a computer of this size. I mean, this is technology development driven by financing. Financing basically making risk willingness to say, can't we move faster? Yes, you can move a timeline if you have money. And how do we get the private capital to come in? You have to show a path. And having multiple ways to do it and having an industry standing together is essential. And then you need to speak to the political level afterwards.
Sorry, I didn't mean to rush you. Sorry. So I think the capacity building that needs to be done for the fusion industry for deployment of the actual machines for commercial purposes is really a lot of the same things that we need in the fission industry as well. And I think if 2050 is the real timeline, I think that fusion will benefit from the capacity building that the fission industry is already working on, because the majority of people, you know, we think about fusion, we think about plasma physicists, right? How many plasma physicists do we actually need? We need welders, we need engineers, we need technicians, we need electricians, we need laborers, right? And I think if we are really going to be doing that tripling of nuclear fission energy by 2035 or 2035, right? 2050. The tripling by 2050. Thank you, sir. Never mind. I get very excited. We're going to triple it by 2035, right? If that is happening by 2050, right, we will already have been ramping up that development of these highly skilled workers that understand the needs in our energy system and have the capabilities to be putting together highly technical machines in a high quality way. So I think this is an area where maybe fission and fusion can partner together on that human capacity development as we're moving forward.
I will slightly disagree on that. I agree that we need to create a workforce for any high-tech application. This is a truth in every area, I think. But in the case of fusion, workforce is a huge problem. It's not only plasma physicists, it's a lot of engineers, it's technicians. Technician UK is a very good example of how they are building capacity in that area, in particular on technicians. In UK, it's amazing what they are doing, and I always invite everyone to take a look. Fusion is moving very fast. I do hope before 2050. I do hope that this private sector pushing with the knowledge coming from the public sector and projects like ITER, we can make it faster. And you need to move faster in terms of workforce. So I would say we need an extra effort on that, not just wait or try to share. We need to increase. We don't need to share. Sharing is great, but we need to increase on that because we are going fast.
I think maybe a way to go forward could be to have some of the same institutions where you can say you also need people to educate people. And that will be a scarce resource. What if you use the same people for at least the parts where it makes sense? And you will need many of the same engineers. But I agree, you need manifold, tens of thousands of these people to build power plants all over. Yep.
I would like to say that, sorry. Yes, the fusion, this is the good news. The fusion is going fast. I think that we think that it's a very good news that the private sector, and the private sector, if we want to go faster, we need to the private sector in the sector. Sorry, it's a fact. We need to the private organization, to the private company in the sector. This is other good news. But now there are other things in the fusion area, in the fusion energy area that is recent. The thing is that we now in 2024 we know that we can do it. Years ago, really we had challenge we didn't know to solve, but now we know that maybe from the engineering point of view, from the scientist point of view, we think that we can do it. The question of how many years can be discussed. Obviously, maybe 10 years, 20, I don't know how much. But this is only a detail, I think. But other thing that is happening is that all the countries, we are starting to speak to regulate the sector from the point of view of each country sometimes. And other times we have international collaborations in order to look for I don't know, agreements, rules, etc., to create these new rules of that we need in the world. But finally, okay, from US, from Europe, from China, from Japan, from Korea, from I don't know, we can work from the point of view of our countries. But if we don't know, if we haven't an international rules in order to create these machines, we are going to lose a lot of time and a lot of money. I'm sure. This is only my opinion.
Yes, in fact, in part, I agree with Gail about the fission industry, because currently on ITER site, a big portion of our contractors are from a fission industry, like the welders, all to put the machine together. They are from the fission industry. But we do have a lot of fusion-specific technologies. So I'm from China. I was working in China for the nuclear, for the fusion nuclear energy. And in China, the way to do it is that trying to put new money, new investment, because ITER gradually they change the capacity, the need for expertise, for construction, for operation, and for the final experiment. There are all different expertise needed. But for this construction, currently we're really trying to invest more money to bridge the gap between ITER and the commercial, because ITER is not covering everything. Not new, we need new materials. We need tritium technology, etc. We do need a lot of. There's still a gap between ITER and the commercial. So put some money, invest some money to bridge the gap, so to keep the team, to keep the force there for fusion. Thank you.
Hi, good afternoon. John Barr, White House Office of Science Technology Policy. My background is in from the NRC side and understanding the safety hazards associated with fission reactors. What are you guys doing, and what have you seen in terms of educating the public and stakeholders on the hazards associated with fusion energy? Because I could see a scenario in the future, even if fission is successful, maybe we don't triple by 2050, but we do something pretty good. But there's still communities that will have some resistance to that. And perhaps with fusion energy can play a complementary role in certain communities. So what's any thoughts there? Thank you.
This is a great question, and I didn't coordinate it with him, because what we started to do at CATF when we started to revise, and we call that part of the program de-risking fusion, is going through all the safety aspect and regulations to say, okay, fine, let's start from the beginning. Let's start which are the real hazards for fusion, and make a study of what could be an hazard for fusion, which could be the consequence, and keeping in mind that not all the designs of fusion machines are the same. So you can have hazards that apply in one design and doesn't apply in another design. So you have to be very comprehensive and make the case for. So we did all this systematic study, and we'll release by the end of this year. So I will keep an eye, and I cannot say more. It will be released soon. Now we are focusing on another piece of work that we are going to release tomorrow, but that is the right answer, to try to understand in a comprehensive manner all the hazards related to fusion, the potential consequence, and based on that, you can start to talk about regulation and the safety principles and etc. But this is the key element, yes.
Maybe a short comment to it. So one thing is the safety. Another thing is actually when you're looking into fission, that you have supply chains, that you have dependencies across the world. And we don't really have that with fusion. So one thing is the safety, which will be immensely important towards stakeholders and not looking towards the next Chernobyl. It is frankly impossible with fusion. You don't have that. You don't have a meltdown. When the plasma hits the walls, it's cooled down. Everything stops. It's like trying to drive a race car and every handbrake in the car is pulled up. You need to make every effort to put them down. This is the game of fusion. I think the safety question begs the same question about where do you get the fuel for fission. And this is really, at least for Europe, a dependency situation where sovereignty and being able to rise again is important really to discuss when we're tripling towards 2050 of fission.
Okay, time flies, so we're just on time. And I hope to express my thanks or my gratitude to all of you for the good interaction, participation, and I would like to see you tomorrow. Thank you.
The world needs fusion, and fusion needs teams around the globe working together on solving the big challenges. One of those big challenges is the development and assessment of a new range of low activation, neutron radiation resistant materials from which fusion power plants can be constructed. But obtaining data on these materials is extremely costly and incredibly time consuming, so the fusion community needs to unite and maximize the benefit from the limited data available. We need a global shared fusion materials database. And this is the perfect time because new, very powerful data processing techniques are currently being developed using artificial intelligence and machine learning. The more data we share, the more we can reduce the current uncertainties about whether the materials will perform. And adding a wide range of data, tables, formulae, graphs, images, microstructural analyses, including information that did not reach publication, will generate new insights into the links between processing, microstructure properties and performance. These techniques can be used to understand the critical gaps in the global database and then to plan the most efficient experimental campaigns, for example on IFMIF-DONES, to fill those gaps. So we need CATF's MatDB for Fusion global database activity, an open access single source of truth for high quality fusion materials data, enabling a suite of machine learning tools. We believe that the creation of a new AI-driven materials database will save millions of dollars and cut years off the global quest for clean, secure and affordable fusion energy.
Hello COP29, my name is Dr. Thomas Davis and I'm the co-founder and chief executive officer of Oxford Sigma, a private organisation founded in Oxford, United Kingdom with the mission to accelerate the deployment of fusion energy around the globe. Fusion is key to the mission of this and future COPs because it has the potential to become a technology that can significantly reduce greenhouse gases whilst producing clean and dense energy. At Oxford Sigma, we develop sustainable materials for fusion power plants, and also we lead the development of international construction codes and standards which enable the standardization of key fusion components. In particular, I am chair of one of the committees dedicated to providing international standardization of fusion power plant construction and operation within the American Society of Mechanical Engineers Boiler and Pressure Vessel Code. The code requires qualified material data to ensure the design and substantiation of safe operation is sound. Therefore, Oxford Sigma are pleased to be supporting the Clean Air Task Force in their mission to create a truly international materials database for fusion designers and vendors in order to accelerate the deployment of fusion energy globally. Thank you.